Everybody, and welcome to the last talk of today. My name is Claus Ibsen, and I'm here with Andrea Cosentino, and we are here to give you a talk about what's happening in Apache Camel, and especially around Camel 3. So let me just go and find the slides and go to full screen mode and give you a little time to adjust the screen and see it. Okay, so I am a software engineer from Red Hat. Been working on Camel for a long time, more than 10 years, wrote a couple of books on Camel, and I am the co-tech lead on Camel together with Andrea. I'm based in Denmark. Andrea, can you tell a little bit about yourself?
Yes, thanks, Klaus. So I'm Andrea. I'm software engineer in Red Hat too, and I'm Apache Software Foundation member, and currently I'm the PMC chair of the Apache Camel project. I'm based in Italy and I live in Rome, and you can find me on Twitter or GitHub.
Thank you, Andrea. So at first, we'll give you a little tour of what Camel is, and especially around Camel 3 with all the new sub-projects and also our change in release strategy. But the main focus of the talk is around the latest innovative products on Camel, Camel K, Camel Quarkus, and Kafka Connectors. And at the end, we have links where you can find more material and also Q&A. So what's Camel? Well, we say Camel is the Swiss knife of integration. Actually, it's the giant Swiss knife of integration. Camel has been around for a long time, and therefore it comes with a lot of functionality. Okay, so it's a Java-based open source integration framework, or library, if you want to picture it like that. It's based on something called enterprise integration patterns, which is design patterns that are distilled in a book. And Camel is a software implementation that comes with these patterns. So you can use this pattern to solve integration problems. And to connect to a lot of different systems, it comes with components or connectors. There's actually a lot of them, more than 300. And then it comes with a very nifty thing. It's how you integrate systems, or is you describe them in Camel using code, Java, XML in Camel Routes. We're going to see that in slides and demos. And yes, it can integrate everything, or almost everything. It runs on all the popular Java runtimes, whether it's Spring Boot or Microprofile and Kafka, Tomcat, and Vertex, and even OSGI with Carafe and Quarkus, which is a fantastic new product we're going to talk about today. And one of the best things in Camel is its community. It's probably the biggest and most active open source community for integration software. It has a lot of contributors. It was created before GitHub even, so the contributor count is skewed a bit because before GitHub didn't know about that, and many of the pull requests we receive are from external contributors, and it's been around for about 13 or so years. As you can see on the bottom, is the graph is the commit history of the product. And I think last time we actually had a holiday was maybe in the 2007 or break into 2008. As you can see, there's commits every day more or less. And then you may say, okay, why is it bigger at the end of towards 2019 and 20? And that's because when we really start building Camel 3, then there was a lot of activity on the product. Okay, we do have sometimes with the slides, they can tease us a bit. So, okay, the next slide is here. So this is probably also the main center of Camel as an end user is the Camel Routes. That's where you define or code how different systems are integrating Camel language. It's a DSL. So on the top, we have a Java DSL and the bottom is XML. From Camel point of view, it doesn't matter if you're using Java, XML, or what you're going to see later with Camel K, you can also use other languages like Kotlin or Groovy and JavaScript even. But here you can see at very high level, you can just specify that we want to take some files and send to a JMS in 2 lines of code. And that's basically it from a very high level. The architecture of Camel is essentially this. So in the center, we have Camel context. Camel context, that is runtime Camel. That is essentially what you use to run Camel. Then the idea is that you can add routes to this context. And in these routes, you can use these enterprise integration patterns where you could do routing, transformation, and so on. And then you have components to connect to many different systems, which are illustrated in the bottom of this illustration. And let's just go and look at that in code. And very basic example is to use a public static void main class. And then what we're going to do is to create a Camel context using the constructor with the new default Camel context. Then you can add routes to it. And to keep this on a single slide, we just use a inline route builder class, where you can see we just say from a timer and a log. Then we start Camel, and just be aware that the start operation in Camel is not a blocking operation. So to keep the JVM running, we just run it for 10 seconds and stop it. Of course, there are better ways to keep a JVM running, but this is just to pull away the curtain and show you there's no magic. Now, in the Camel routes, you can use another way is with Spring Boot. To use Camel routes is to just create a class, extend the route builder, and then annotate the add component annotation Spring, so Spring Boot can discover this class and make Camel use this route. And in this class, you can use the dependency injection from Spring with auto-wired and what else there are from Spring, and then just knock yourself out with the code. If you're using Quarkus, the same thing. Actually, Quarkus itself can kind of discover these routes without having to use annotation. You just create a route, and it's discovered by Quarkus and Camel. Of course, with Quarkus, if you want, you can also use dependency injection using CDI, for example, as shown on the slide here. And also, Quarkus supports the dependency injection annotation from Spring. So you can also, if you're a Spring user, you can just keep using Spring annotation, and Quarkus will happily use that as well. So let's talk a bit about what's happening in Camel 3, which is mainly around separating Camel into multiple projects. And for that, Andrea will tell you more about that.
Yeah. Thanks, Klaus. So basically, when we start the Camel 3 project and we start the activities related to this, we wanted to create an ecosystem. So the main activity was to split the project in multiple sub-projects and adding new stuff. So we have the core Camel, so the Swiss knife of integration there, and this is the milestone. And then we have Camel Spring Boot, and this is your runtime if you want to run on Spring Boot platform. Then we have Camel Karaf. So if you like HostGI container and in particular Karaf, this is the other project you could use. Then we have Camel K, and Camel K is one of the new projects in the ecosystem, and is basically Camel for the cloud. And so the K can be for Knato or Kubernetes, and this is a really interesting project. We will see this later during the presentation. Then we have Camel Quarkus, and this is another project we added to the ecosystem, and is based on the Quarkus platform. So for optimized JVM, and in particular with GraalVM, and this is another interesting project, and we will see later with the demo. And last but not least, the Camel Kafka Connector project, the newest project in the Camel family, and this is based on Kafka Connect framework, and we will see this later as last demo. Yeah, about the Camel releases and the approach we want to use, we decide to follow the Java approach. So we already released first long-term support release, which is the 3.4, and we already released 3 batch releases. So now we are at 3.43, and the idea is to release another LTS long-term support release by the end of by the end of this year, and in the middle we will continue to innovate and add the new feature and new stuff in those releases. So we released in the last days the 3.5 release, and we are already working on 3.6. And one interesting part is that 3.5 is the first build, the first release of Camel, which is able to build with Java 14. And this is, yeah, more or less what we are doing in terms of releases. Yeah, let's get back to Claus.
Thank you, Andrea. Okay. Yes, sorry, the slides are not moving. So let's get to the main topic of this presentation and look at the latest innovative sub-projects with Camel, especially around Camel K. So what is Camel K? So we say it's a lightweight integration platform based on Camel, born on Kubernetes with serverless superpowers. So you can run Camel K on just Kubernetes. It also runs on OpenShift, for example, and other Kubernetes distributions. But you can get the most power from Camel K if you run with Knato. So how and why should you care about Camel K? So developers that are doing, in application or microservice or serverless things for the cloud want to focus just on the business logic or integrations and not care so much about, particular Java runtimes, whether it's Spring Boot or Quarkus or Tomcat or whatever it is, and fiddle with those app servers and things like that. They just want, here's my code or my app, put it on the cloud and run it. This is actually what Camel K is all about for Camel. So you can just write a file with your Camel route or your integration logic. So on the slide here, it's actually Groovy, but of course it resembles Java. So it takes it listens to a Telegram bot and does some message transformation, send to a Kafka topic and take the message from that same topic and call HTTP service and so on and so on. So you could just knock yourself out in code. Then you can say to Camel, Camel K, there's a tool for that with a binary. You can say Camel run and then the name of the file. And then Camel will materialize and make that run on your Kubernetes cluster, whether that's running locally, which we're going to see for the demos. They run on my laptop, but of course you can also run on premise in your own organization or in the public cloud or whatnot, just a Kubernetes cluster. And it's the same user experience for you, Camel run and the name of the file. Before the demo, just give you a high-level architecture of Camel K. So on the two slides, we have, sort of like the develop environment. You can write your code, whatever tools you want to use there, and then there's the Camel CLI command that, can take your apps and deploy it in the cloud or on Kubernetes. And it says remote cloud, but again, I want to stress what we're going to see here is running locally, just any kind of Kubernetes. So a great feature with Kubernetes is that they made it very extensible, and you can extend Kubernetes using something called a custom resource definition, CRDs. So what we've done is to make integration custom resource or Camel custom resource. Then those custom resources are then supervised by operators, and we have a Camel K operator that are installed and running in the cluster. That one is sort of reacting upon custom resource definitions that are changing, come and go. So when you install something, there's a new CRD. If you update one, there's an existing CRD that's being updated and so on. So the operator watches those and reacts and figures out what to do. This is where all the smarts lies. And the Camel K operator is able to, take that, what you want to run, and figure out how to do that. And build a pod, build a container, and now build a Docker image and then run that as a container. And depending on your environment, if you have Knato installed, you can run it, serverless with Knato. If you don't have it, you can just run a normal Kubernetes deployment and many other things. It's quite elaborate. And there's a host of other talks that goes more in depth in Camel K. But let's see it in action. So before I switch to real life, I just want to say that what you're going to see here is a terminal. We're going to watch the pods in Kubernetes running on my local machine, and then do some changes and see that all in action. So let me go here. So in the bottom, I have kubectl get pods. So you can see it's watching the namespace and then So you can see the pod activity. You can just see the operators running. And up here, I'm using Camel K, the latest GA 1.1. We are working on 1.2. There's a number of releases they just need to get out, and then Camel K will be able to release those. Watch this space for a new version. But here I'm actually on my desktop, so I can. There's not so much file. I can say Camel init. I want to create a new Camel file, and I call it a awesome K Java. And then I can actually edit this file. I'm just using a Sublime editor, basic editor. There's no Matic for that. Of course, you can use your regular Java editors. We're going to see some others. And what it does is give you just a little camel route from a timer and does something. That's all look nice. So what I want to run that one, I can say run, then the name of the file. But I want to run it in dev mode, /dev. So it will actually tail the activity of the log. So we can see it booting up here. It's running now. It says, hello, Camel K from Java. And you can see on the bottom here, the pod is running. So I can go up here and say, bye, Camel K. And now I save the file. You can see it does immediately hot deployment, and the new pod is starting up. And now it says, bye, Camel K from Java. That's really awesome. And I can also, for example, change it to run a bit faster, 1, 2, 3, and save the file. And we get an update again. And yes, oh, an error. Okay. Oh, so you can see now I get a compile error. So I'm missing a semicolon here in the log. Yes, it's the on purpose. But just to show you, okay, something under the table, I am just fixing that one. And it's telling the log, and it runs again, and it goes faster, and so on. Okay, that's all fancy and so on. So let me just go and stop this one, Control-C. You got the nice user experience, the pod and the app is terminated and is gone, right? So if you go and look at the website for Camel, you got the news, and you can read about a few things with Camel, and the sub-projects is coming here as well. So I just want to go, for example, if you choose documentation and Camel K itself, you can get guides on how to install it, some guides on the different Kubernetes distributions, and just be careful about the configuration or the registry. So just to give you some indication, how does Kubernetes run the code I just wrote? Well, it's actually pushing that code as a custom resource defined into the Kubernetes cluster. So it sits in there, the operator detects that one, then the operator is actually building that container image. So it does a Docker build if you kind of want that. And then you need to push that to container registry, because that's the standard, or that's the way that Kubernetes is able to pull images and run those as containers. So that's what we see as one of the most trouble thing when getting started with Camel K, is that it depends on what distribution you have, whether or not you have a container registry. For example, the Minikube, there's no container registry out of the box, but you can enable one, just say Minikube add-on registry, and you can turn that on. And that's what I've done. But if you run on Amazon, there's a container registry you might have, so you need to have sort of like credentials to log into that one. And we have some guides for that, just in case you're stumbling on that. Otherwise, you can find, documentation for the project, and so on. Of course, this is going to be improved over time. But if you want to see some examples, then we have 2 places on GitHub. The Camel K examples, these one are actually more like a tutorial style. So there's 10 or 11, so they're a bit longer. They are much more serverless, going with Knato and so on, and using Sask, like S0 and S3 and many other things. They are using something called a DIDEC as the tutorial, which allows you to run them in Visual Code and whatnot, sort of like a click next, and very nice user experience. But if you want to have some quick, very quick ones, like I did with the Camel init, then I would recommend just go and look on the examples in Camel itself. It's sort of like a mixed bag of examples. You can see there's Java, Groovy, JavaScript, and so on. For example, if we take this one, this is a Groovy script. even though it looked like Java, but you can see there's no semicolon. You can run this one directly from Camel by clicking, for example, on the raw one and copying that link. I can say Camel run, and now if I say Camel get, it says Camel. There's a Camel application called cron, and it's running. But if you look at the pods, there are no pods running. And why is that? That's actually because it's because Camel K operator has detected that this application is a cron. I want to schedule this to run every minute. That's actually the cron syntax for that. So it actually installs it as a Kubernetes cron job instead of a always on pod. Now you can see it actually runs and it was completed. So every minute Kubernetes will start this application and run it until completion, and then so it's actually a cron job. But I didn't have to do anything about it. I just wrote the code as I wanted, and then Camel K operator figures out, okay, this is something that could be turned into a cron job instead of running all the time, and then it does that for you. So it's optimized for the serverless environment. And I can say Camel get again. I can say Camel delete cron, and it's deleting that one. It cleans up all the resources for you. So let me just say another thing. Actually, just one. This is something I'll say for you guys. So let me see. But I don't know, was it the Kotlin ones? No, I think it was the JavaScript ones. So there's a JavaScript application here. I have not run this before on my Kubernetes clusters, so I'm actually just gonna say try to run this one, but using another alternative. Is you can say GitHub, then the organization name, that was a Apache, and then Camel K examples, and then the routes.js file. Let me see if I typed that correctly. And then actually say Camel get. Now you can see it actually says building kit. And this is what I was saying is that we installed a new integration. It built on now you can see it's starting. Now it's running. So what happened was that we installed a Camel custom resource with a Camel route using JavaScript, and Camel K has not been running integration before with JavaScript or that particular set of dependencies that they need to run this one. So the operator inspects this code here, JavaScript code, and figures out, okay, this is a Camel, you need the timer, I need JavaScript, and I need X, Y, and Z. And then it goes and look whether or not it has some sort of already existing built container image it can use to run this one. If not, it will actually build a new container. And that's what we saw before. And it takes, it's rather fast, 10 seconds or so to build that one. So now it's actually, if you kubectl get builds, that's our Kubernetes native builds, and you can see these are the ones that have been built over time since I installed Minikube. And the last one was just run for 65 seconds ago. So now we are running that one, and if we kubectl parts, I can say it's done. That's a nice little log tail for Kubernetes, so you can watch inside any running pod without having to type the full pod name. As this is from what we saw here from the JavaScript application, hello Camel K. Of course, they all say that one. And it's the same user experience. You can update this one, and it will, in dev mode, for example, and whatnot. And we are getting, actually prepared just one more thing, just to give you an idea. So I'm using a tool called K9S, which is a nice way to browse inside a running Kubernetes cluster and jump between namespaces and whatnot. And now we have this JavaScript application running, so I can actually go and look for integrations, and the routes is here. And I can view that in YAML. And here you can actually see, I'm pulling away the curtain now. You're seeing all the triggers for us now. So the CID is actually this one. And in the CID, you can see the code. So the code is here. So essentially, if I can actually update this CID from some sort of tooling or editor here, and the application will update itself because the operator will act. So, we can try that if we want. And this is where I'm going a bit off script. So I don't do this normally at home. So I say, by Camel K3, save this one. And you can see now it's changing, at least in K9. If I go back here and I say, you can probably start it to run again, Stern routes, and now it will say something about by Camel K3. So, it was updated. Okay, enough of Camel K. Let's move back to the slides and move on to continue. Go back here. That was the quick Camel K demo, maybe not as quick. So Camel K is not only Java, as mentioned. We saw Java. There was also a bit of Kotlin and Groovy and so on. And you can use XML, YAML, and JavaScript. These are the languages that Camel K supports currently. Another product that we're going to touch upon is Camel Quarkus. So Java has been known to be slow, especially two areas. It has a density problem on the cloud, at least. So when you start to run your workloads in the cloud, then capacity problems or density problems actually matters. Because at alternatives, you can run a lot more Go or Node application than even the best traditional cloud-native Java stack application, whether you're using Spring Boot or something yourself. They tend to be a bit fat. And of course, that's what you get from a JVM that was built for a different purpose, 25, to run as a big monolithic process for a long time, like an app server, host the apps and undeploy them and so on. But now on the cloud, it's a lot. Just run the process when you need them and scale them down to 0 and don't run them, and all the Cloudland container can manage that for you. So we don't need that, and that's a big problem with Java. Another one is really a scaling problem, because the JVM itself is built to run for a long time, so it's okay to take a longer time to start up and get warm and so on, and then be very efficient, and then take time to shut down. It doesn't matter. But in the scaling problem, especially with the serverless and Knato, we want to be able to scale up quickly and scale down as well and gracefully, and especially scale to 0, so you can turn off resources you don't need. And that's these two things is that something that Quarkus aims to solve, among other things. So the tagline for Quarkus is that it's supersonic subatomic Java. So something, it's referring to something that is very small, subatomic size. Quarkus, that is the smallest unit inside the atom. So it's very small and nimble. But so this is the longer tagline. So don't bite your tongue on this. It's basically just a Kubernetes cloud native first for Java that can run on JVM or be native compiled using GraalVM. And that actually matters because you can reduce memory and also the time to response. What's it called? The boot time, start up and shut down. But especially the first time to response matters as well. So, some frameworks will cheat and say they are started, but then you get a request and then they have to initialize stuff and do stuff, and that takes time. So this is a test where they measure different approaches with native compile, where it does the green. The blue is the sort of in between, just running on JVM with Quarkus, and the gray one is the traditional without Quarkus, for example, Spring Boot and so on. That matters a lot. Okay, if I can move the slides. So we do once in a while get these slide problems. Okay, Google Slides. So what I did here is just to show on a slide, I have native compiled the HTTP log example from Camel Quarkus. So if you can maybe barely see it, but Camel itself starts in 1 millisecond. And Quarkus and the entire application starts in 24 milliseconds. It's a 50 megabyte binary, single binary file with everything it needs. It takes up 27 megabytes of total memory. And that's without tuning. And that's compiled with GraalVM, the latest one on a Java 11. You can also choose Java 8. Java 8 tends to be still a bit more efficient, so they have some work to do to make Java 11 better than 8. But why can Camel start up so fast? And that's because Camel Quarkus product is fantastic. We do a lot of ahead of time optimization for Camel because we know this is Camel running, so we can do a lot of pre-wiring and warm up and other bits and whatnot, and do a lot of dead code elimination and many other things, sort of like what Camel K can do just for regular apps. And then, what it ends up with on native compile, you would just want to start Camel, then, everything is warmed up, and it's just a matter of starting the Camel routes. So all the Camel routes, and they are very fast to start. So that's awesome. Just gonna show a little demo of that, maybe more quicker than last time. So what I have here is the HTTP log example from Camel Quarkus. I am loading that in Visual Code. So basically what you get from a standard example with Quarkus is a REST service /hello. It returns hello. And then I add a Camel route and using actually something a little more coming in Camel 3 called endpoint route builder. So all these Camel endpoints, I can actually use them in type-safe way now. So I can choose. So these are just, regular Java code, all the options you want to configure on your endpoints. If you can see, these are the options that you can use. HTTP method restrict is something that is on platform HTTP component and so on. But basically, I can run this one using Maven Quarkus Dev. This is sort of like the idea with Quarkus is that you can boot or run Quarkus using a Maven plugin in developer mode, and then you can just hack on the code as you wish, and then it will automatically update itself. So if I go on localhost 8080, then I get my standard Quarkus hello screen. If I say hello, that's the hello you'll get from Quarkus. And if I say Camel hello, because I had that one, it says Camel runs on. If I go and say Camel 3, and save that one, and go back here, oh, I was a bit too fast. Camel 3 runs on. Okay, so kind of same like with Camel K. And you also get health checks if you include that one. And metrics from the micro profile. You can see these are the number of messages processed, and these can be consumed by infrastructure in your cloud, so you can get metrics and health checks and everything like that out of the box with Camel and Quarkus. That's all fine and whatnot. So let's just stop this one. So what I've done as well is to compile this one. So if I say the runner here, I start this application. This is native compile. It started in 15 milliseconds. And again, if I go to a web browser, I get the same application. .java is just Camel hello. Now it's just in the native one. It goes back to say Camel because I didn't recompile it. But down here, interesting is that I have a little script to see how much memory that one uses. About 30, and I have the script itself is actually counted itself, so that's you have to subtract a few megabytes. So 28 megabytes for that one. But what I really want to demonstrate is I have another script called run many. So what I do now is I start 100 instances of this application, each with their own port number from 8,000 to 8,100. And now they're running. And if I run the script, you can see they take about 2.6 gigabytes of memory. These are all running on my computer here, so I can say 8002, Camel hello. So that's 8002, 8077, whatever port number you want to choose. And they also come with health checks and metrics and everything like that. So let's say one more Camel hello. So now this one is running. So for example, I'm 33. Now I want to kill all of them. I say PQ Camel. So all the processes are there. Now I'm going to start them again. And I go back here. And it's starting again. Right, that's really fast to have native compile, Quarkus, Camel, and everything boot up immediately. That's for serverless and really, really fast. Let me just kill them. And we go back to the slides for continue. And so next up is the very exciting product of our Camel Kafka Connectors, and Andrea is talking about that.
Thanks, Claus. And so, as I said in the releases part, the Camel Kafka Connector is the newest project in the Camel ecosystem, and is based on the Kafka Connect framework. So what is Kafka? Just as introduction, if someone didn't heard about it, is a distributed streaming platform, or if you want, a PubSub messaging broker. And as Camel is an ecosystem, so there are multiple parts in Apache Kafka, and in Camel Kafka Connector we focus and we leveraging what there is in the Kafka Connect framework. What is Kafka Connect? So is a framework, and basically it helps the user to being able to integrate Kafka with external systems. So a user can define source or sink connector to stream data in and out of a Kafka broker. So you just point your topic or your group of topic, and you will consume or produce stuff from an external system or to an external system through these Kafka topics. And those connectors are pluggable, so you can use already existing connector, or you can write your custom connectors and use that. And Kafka Connect has a bunch of features. The most important are that is distributed and scalable by default, and there's also the automatic offset management that is really important to being able to restart the consuming or producing stuff from a particular point. And yeah, more or less the Kafka Connect is this. And okay, so Camel Kafka Connector is a big Kafka connector built on top of Apache Camel, and it was started as a proof of concept at Red Hat, and it was donated to the Apache Software Foundation in December 2019. And the basic idea is to being able to reuse what we already have in Camel as component by generating Kafka connector based on these components. And so in this case, you will have a source connector if the components support consuming, and a sink connector if the components support producing. So you may have connector with both source and sink connector, or just one of them. And we already have 4 releases out, and the 5th release is already on boot and is based on 3.5.0 of Camel. And we have Knato generated documentation, so you are able to read all the options and the parameters you can use in the Camel Kafka connector, and we are trying to improve the documentation. And we are adding also some examples. So in the demo, we will show how we can use these connectors, and in this case we will use an AWS S3 connector as source connector. So we will consume a file from an S3 bucket, and we will use a sink connector on the other side to being able to stream from a Kafka topic the content of this file to an SQS queue. And all this stuff can be run obviously in Kubernetes, and you can do that, for example, with Streamz, which is a project related to Kafka, to being able to run your Kafka broker and your Kafka cluster in Kubernetes through an operator. And yes, I think I say all. And so it's time for the demo, which we will see. Okay, so one of the main target of this project is being able of using Camel and the Camel Kafka connector only through configuration file. So basically, our idea is being able to do everything through configuration. If you want to do something hardcore, you can do that. You can still do that. So you can write your own code. You can write your own converters, transformers, aggregation strategy, whatever you want, and add this stuff in the configuration. But basically, this should work out of the box. And this is an example. So you just have to declare what is the class you want to use. And in this case, for example, for AWS S3, you want to use a source connector. So you just have to say, I want to use this connector class, define what is the key converter for the message, the message coming through this, from this source to the Kafka topic, what is the converter for the value. And then you have this mixture of option of Kafka Connect and option of Camel. And in this case, there is, for example, the max poll duration, which is how much time the bowler of Camel will have to bowl. In this case, it's 10 seconds. And then you have other stuff like the AWS secret key, access key, the region of your bucket, and so on. All this stuff is documented. So on the Camel website, you have everything you need. And in this case, we are using the Camel source URL, but you can do that through single option. So you should have, for example, a Camel source stuff S3 and so on. And no problem, Klaus. So I was talking too much.
Okay,
no, and for the sync side is the same. So you just have to write your own your connector class, declare that, and just define the configuration. Yeah. Okay. In this case, is the queue is Camel 1. Okay. So the video should be starting. Okay, this is an installation of Kafka. It was already set up, and in this case, we choose to use the plugin path approach. So we declare a folder, and we will download the connector there. I already downloaded the connector in this case. So I have the S3 connector and the SQS connector, and I just have to unzip them through the plugin path folder, and this is already done, as you may see. So you have everything set up in this case, and after that we should be able to do some more stuff for setting up the stuff. In this case, I already prepared 2 properties file, and we can see the S3 connector properties as we saw in the last slide. So in this case, we are pointing to the Camel Kafka connector bucket, and we will upload the file there, and we'll consume the file from there. In this case, the file will be deleted because by default, delete after read is equal to true. So once the file is consumed, it will be removed. And on the other side, on the sync side, we have the AWS SQS connector. In this case, we are pointing the Camel 1 queue, and we have secret key, access key, and the region for this particular queue. So we expect to have the file, the content of the file there. And in this case, the content of the file is hello from Camel Kafka Connector. Okay, now we are ready to run the example. So we need to run Kafka, the Kafka broker. So we first start Zookeeper, and then we will start the server. In this case, it's standalone, but it should work similarly into a Kafka cluster on Kubernetes. And this is how we can start the connector. So we just need the connect standalone executable, and just point to the option of Camel Kafka Connect stuff generic and the connector properties. So we provide 2 different properties file, one for S3 and one for SQS, and the connector will start. So you will see there are 2 Camel route, one consuming from S3 and one producing to the SQS queue, so Camel 1. Now we just have to upload the file on the S3 bucket, and this is what I will do in a second. So the bucket is Camel Kafka Connector, and we will upload the hello message from who we saw in the shell. So we just need to load the file. Yeah, the file is already there. We will see once we refresh that the file will be removed. And on the SQS side, so in the Camel 1 queue, if we poll the content of the queue, we will see that we have a message with hello from Camel Kafka Connector. And to demonstrate we are not cheating, we will do the same operation again in this video. So we will upload the file again on the S3 bucket, and we will see there is a second message with hello from Camel Kafka Connector. So more or less, this is how you can use a connector. So as you see, we didn't touch code. We just use a configuration file. And this is one of the main strengths of this project and one of the aim of this project. So you should be able to do everything, and leveraging the power of Camel also in the Kafka network. And this is really promising. Okay. Yeah. Get back to Claus now.
Thank you, Andrea. So that was great to see, as always. So before the Q&A, just give you an idea where you can find more material. Of course, the website. There's also a YouTube video of that small Camel K thing I did. And also on the Quarkus things, how to run 100 instance quickly and so on. And there's a longer Kafka Connector demo using different connectors than S3 and so on. And then for the last thing I actually want to highlight, that's Nicola. He's one of the co-creators of Camel K. He just recently had a presentation at KubeCon EU 2020, so it's 2 weeks ago or something like that. 35 minutes really was worthwhile to watch for if you want to get more details on hands-on on Camel K itself, and especially the serverless part with Knato. The Camel examples, we have many of them. The main examples, Camel K. Camel K was divided in two parts, more details as tutorials, and then the small snippets, the first link. Quarkus examples, actually we are splitting them up, and it's coming in its own repository. Kafka Connector examples, I believe, Andrea, you have a fair number of examples now. And of course, okay.
Yeah, go ahead.
Yeah. Okay, I just want to say, of course, Camel works really awesome as well on Spring Boot. So we also have about 100 or so examples there. So there are plenty of information and to see there. And so let's go and see if there's any Q&A. And just you can find us on LinkedIn, Twitter, and other social media. And of course, on GitHub, if you're using that. And if you kind of like the Camel a bit, then we appreciate a little star. Thank you very much for that. And now I'm gonna go and look at the stop. I'm not sure if I'm supposed to click stop sharing and then go back to back to that. This one, yes. So I'm not sure if I can actually see any questions in any Q&A panel somewhere. Okay, so there's a session panel here. It says hi, greetings. I think everybody's just saying thank you. Okay, so that's really great to hear that. I hope you enjoyed the talk. It's really interesting for us to be able to tell the world about Camel. Unfortunately, I was really looking forward to visit Istanbul. I have never been there. I know it's a great city. It's between Europe and Asia. I want to see that part of the world as well, but unfortunately, how the world works now, we have to do them from our home. So keep in touch, and remember, you can always reach out to us in the Camel community. We have, there's the website. There's also links to where you can reach out to us using chat. We are on GitHub chat, but we are moving to Zulip in a bit. So, but anyway, you can find that details on the website. So, any final words, Andrea?
Yeah. Thank you for having us, and we hope to be in Istanbul maybe next year, and we hope coronavirus will finish at some point, and to enjoy, see all of you in face and being able to talk in person.
Absolutely, this is it's a different experience to be able to be out there, and I really love conference where you have these engagements with the audience and people in those hallway conversations. That's really inspiration. So anyway, this is recorded, so I'm pretty sure you can find this online as well later on from the organizers. So I also want to thank Ursel and his team for inviting us and having myself and Andrea on board. So take care, guys.
Cheers. Thanks a lot. Bye.
Bye.
Thanks for having us.